change going to be? Okay. Cameron? What's the constant rate of change? That's okay, I'm still calling on you. What did you get for the constant rate of change for problem number 1? Huh? Constant rate of change. Jonathan? Anybody constant rate of change? Huh? 28. Guys, how do we find constant rate of change again? What are you supposed to be doing to find constant rate of change? Yeah, you're right. So you find the difference from the numbers on both the top and the bottom, or from left or right, what the change is occurring. Hence the reason it's called constant rate of change. You have to find the change that happens. So from 56 to 140, we're increasing by 84. To go from 140 to 280, we increased by 140. To go from 280 to 392, we increased by 112. That's the change of the y value. So we had to find the change of the y, and in this case we had several different changes. So we had an 84, a 140, and a 112, and then we're going to put that over the change that occurred in the x's. So the change that occurred for the x, we went from 2 to 5, which was an increase of 3. From 5 to 10, which is an increase of 5. From 10 to 14, which is an increase of 4. So that was a change of 3, a change of 5, and a change of 4. When you simplify them, they all simplify to the exact same value, which is 28. Every single one of them simplifies to the exact same value of 28. So that means your constant rate of change in this case is 28. Now, identifying if it's proportional or not is a little bit different. For proportionality, you have to check each of the individual ratios, the individual points. So we have to check the point 256. So we're going to do 56 over 2, which simplifies to 28. Then we have to check 140 over 5, which simplifies to 28. Then we have to check the 280 over 10, which simplifies to 28. And then check the 392 over 14, which also simplifies to 28. Since they're all equal to each other, this indicates that it is proportional. Please do not get these two things mixed up. Do not get these two processes mixed up. Constant rate of change and proportional relationship are different, because you can have a constant rate of change and not be proportional. It's perfectly clear to be able to have a constant rate of change and not be proportional. Okay? So for number 2, what's the rate of change, the constant rate of change for number 2? Rachel?
2.
Not 2. Not 0.75. So Rachel, you were close, but you did x over y. You did the change of x over the change of y. You need to do change of y over change of x. Okay? So in this case, here we changed by 8, then we changed by 2, then we changed by 30. For our change of our x's, we changed by 16, changed by 4, and then changed by 60. The constant rate of change indicates that we have to do the change of the the change of the y over the change of the x. So the change of the y, so we've got 8 over 16. We've got 2 over 4. We've got 30 over 60. Each one of these is going to simplify to 0.5. 0.5. So what you did, Jonathan, is you just did 15 over 20. That's not constant rate of change. Constant rate of change is how the points are changing from one to another. What you checked is you checked the unit rate for the point. You only check unit rates for each individual point if you're checking for proportionality. Constant rate of change is how is this changing to this, changing to this, changing to this. There has to be a change that's occurring. Okay? All right, so now for the proportionality, I'm going to check each of the individual points to see if they're equal. So for proportional relationships, 15 over 20 should be the same exact thing as 23 over 36. Well, 15 over 20 is going to give us 0.75, but 23 over 36 is going to give you 0.64. Right off the bat, you can tell that those are not equal, so you don't even have to check the rest of them. That is a non-proportional relationship. So again, you can have a constant rate of change. The constant rate of change is 0.5. So it consistently increases or decreases by the same value, but yet it's not a proportional relationship. So that means it's a straight line. It just doesn't start at the origin. So what I want you guys to do right now is on the next page, I want you to write down the following rules. We didn't get a chance to write these rules down yesterday. But basically, if it's a straight line, not through the origin. If it's a straight line not through the origin, it has a constant rate of change. But is not proportional. It has a constant rate of change, but it is not proportional. If it's a straight line through the origin, then it has a constant rate of change, CRC. It is proportional, which means it's got that consistent unit rate from point to point. And then it also has something that we're going to talk about today. It can also be called a direct variation function. And then the last thing, if it's a curved line, so if we graph it and it's curved, then that means there is no constant rate of change, no proportionality. So straight line through the origin, constant rate of change, proportional, direct variation. Straight line not through the origin, just has a constant rate of change. Curved line, nada. No constant rate of change, no proportional relationship. Everybody clear? Okay, so what you're going to do right now is you're going to glue in our notes for today. You do not need to cut them. They are ready to just be glued right in. If you need to fold them, you can fold them, it's fine. All right. So for our direct variation, when we're talking about direct variation, the idea of direct variation, it's kind of like what we've been talking about, finding that value of y over that value of x. It's almost like the proportional relationships. If it's a proportional relationship, then that specific unit rate is called your constant of proportionality, your direct variation. And it's very, very easy to find. All you have to do is take your y value and divide it by your x value, and that gives you your direct variation. So you're just going to take your y, and you're going to divide it by your x, and that will equal your k value, your direct variation value. So y equals k times x. Okay, that's the equation that's set up. Y equals k times x, otherwise known as k equaling y divided by x. If you take your y and you divide it by your x, then that's going to equal the k value, k being your direct variation. So k is your direct variation value. So all we're going to be doing here is we're just going to be solving for our direct variation and then graphing it. If it is graphed correctly, it will form a straight line that goes through the origin. So if you've graphed it correctly, it's going to form a straight line through the origin. Now remember, it has to be y over x. A lot of times people see graphs like these, and they immediately want to do the top of the graph over the bottom of the graph. But the top of the graph represents the x values, so I'm going to go ahead and highlight those in orange. And the bottom of my graph happens to represent my y values. I'm going to highlight that one in blue. And when we set this up before, we stated, hey, k has to be set equal to y over x. It's y over x. So that means I'm taking each of my y values and putting them over my x values. So I'm going to set it up as 5 over 1. I'm going to do 10 over 2. I have 12.5 over 2.5. And I've got 15 over 3. So each of those are the setup for my direct variation. And when I simplify them, they each simplify to the same value. They each simplify to a value of 5. So it's almost like you're checking for proportionality, but with direct variations, your proportional unit rate is it's called your constant of proportionality, or your direct variation value. So k is equal to 5. Okay, now graphing it, you just come over to your table and you graph each of those points. So 1, 5 means I'm going to start at the corner, go to the right 1, and go up 5 units. Then 2, 10 means I'm going to go right 2 and up 10. .5, 12.5 means I'm going to go over 2.5 and then up 12.5, which means it's going to be in the center of a box. And then 3.15 means I'm going to go to the right 3 and up 15. Okay, and then when I connect them, again, because it's a direct variation, it's going to form a straight line, and it is going to connect to that origin. Jonathan, honey, all I hear is you just talking, talking, and talking. All right, let's go on to the next problem. It says the height of water as a pool is being filled is shown in this graph. So the height of the water is being shown here. After a certain period of time, how much water is in there. We want to determine the rate in inches per minute. Inches per minute. So all I need to do is pick out one of the points and set it up as its y value over its x value. It doesn't matter which point you pick. You can pick the first point, the second point, or the third point. Which point do you want? First, second, or third? Second? All right. So first thing we need to do is identify what the coordinates are for that point. So what's the x value for this point? Who can raise their hand and tell me what's the x value, the x number? Sherlyn? 10. Thank you, Sherlyn, for raising your hand and not saying it out loud before I called on you. That's the x value. And what is the y value for that point? Jonathan? 4. So there's our x and there's our y for that specific point. Now remember, direct variation, our k, is set up as what over what? Y over x. Y over x. The most common mistake is everybody wants to do larger number over smaller number, and that's not the case. It is y over x. So we're going to put 4 over 10. And what is 4 over 10 going to simplify to? 0.4. So that means it's 0.4 inches per minute. That's our direct variation, our constant of proportionality. The pool is filling up 0.4 inches every minute. That's our K. Any questions so far? All right, go on to the next page then. Huh? Well, the next one's a little bit different. All right, so for this one, what I want you guys to write up at the top first is this word, constant of proportionality. This is the same thing as the direct variation. It's just another way of phrasing it. Constant of proportionality. Is the same thing as direct variation. So if they say direct variation, proportionality. If they say constant proportionality, it just means direct variation, okay? So in the problem it says Neil is practicing for his typing test. The equation y equals 45x represents the total number of yards or words y that he can type in x minutes. We want to identify the constant of proportionality and then explain what it represents in the situation. So based off of the equation, what's our constant of proportionality? 45. That's it. It's that simple. Direct variation is y equals k times x. Y equals k times x. That was what we wrote in the very, very, very beginning of the notes. And we're just wanting to identify that k value. So it's 45. So k equals 45. Now they want to understand, hey, well, what does it represent? Well, k is whatever your y is per whatever your x is. So that means that this is 45. What's our y represent? words, right? It says words Y, so it's 45 words per what? What's our X? Minutes, right? 45 words per minute, because it's X minutes. Okay, go ahead and do number 2. All right, what's my constant rate of change? 55. And what does it represent? 55 what per what? Miles per hour. 55 miles per hour. Okay, so our direct variation is at 55. So K equals 55, and it's going to represent 55 miles because it's Y is the traveled miles, and it's per hour because X is going to represent the hours. And that's it. Wow. All right, last one. Now, just to keep in mind, not every single situation is a direct variation. Remember when I just told you guys right after the bell work, if it's a straight line but it's not through the origin, then all it has is a constant rate of change. In order for it to be a direct variation, it has to have a constant rate of change, and it has to be proportional. The only way that it's constant rate of change and proportional is if it's straight and it goes through the origin. So not every single line, straight line, is going to have a direct variation because it's not always proportional. Okay? So here, if we state that pizzas cost $8 each, plus we've got a $3 delivery charge, we want to show how much is it going to cost for 1 pizza, 2 pizzas, 3 pizzas, and 4 pizzas. Okay, so let's talk about the pizzas first. We know that we want to set up a table that represents how much it's going to cost for 1, 2, 3, and 4 pizzas. That's what it says to us. How much is it for 1, 2, 3, and 4 pizzas? So the cost, if I buy 1 pizza, that pizza costs $8, and I got to get it delivered. So how much is that 1 pizza going to cost me total? $11. Now, if I buy 2 pizzas, why only 19? Why is it not 22? You already paid the delivery charge. That delivery charge gets paid only by the first pizza. After that, you just pay $8 each time. Okay, so this is now going to become 19. For 3 pizzas, it's going to be what? 27. And then for 4 pizzas? 35. Very good. Okay, so here we've got our pizzas, we've got our cost. Now, obviously, this graph, it's a little bit light. It's kind of hard to see it, and it's not big enough for us to count by singles to get up to 35. So what I'm going to do is I'm going to go ahead and just skip a couple of numbers each time, and I'm going to count by, we'll say by 5s, yeah. So we'll do 5, 10, 15, 20, 25, 30, 35, 40, and it keeps going on and on and on. For the X's, we can count by 1. So 1, 2, 3, and 4. Okay, and then we're going to graph those points. So at 1, it goes up to where 11 would be. At 2, no, you don't have to put the zigzag, the break in the graph. At 2, it's going to be up to where 19 is. At 3, it's going to be up to where 27 would be. And at 4, it'd go up to 35. Okay, and if I connect it, is it going to be proportional? Because it doesn't cross through the origin, right? It's not going to cross through the origin. Okay, so it's a non-proportional graph. It's a non-proportional graph. So it has a constant rate of change, though. The constant rate of change is going to be 8. Constant rate of change is going to be 8 because each time we're increasing our x by 1, we're increasing our y by 8. So it does have a constant rate of change. It's just not a direct variation. Because 11 over 1 is not the same thing as 19 over 2 or 27 over 3 or 35 over 4. Those are all going to be different values. Everybody clear? Okay, so you guys have a worksheet that's going to cover solving proportions. It's going to cover constant rate of change from yesterday, and it's going to cover direct variation from today. It is due tomorrow, and you do have that test. Remember, we were talking about the test. It is tomorrow, so that way you guys can get started on the final exam review Thursday. Okay, so the test is going to cover solving proportions, constant rate of change, and direct variation. It's 10 questions. The majority of it is multiple choice. You guys did really well on last week's test. You'll do perfectly fine, I'm sure, on this week's test as well.